In this tutorial we'll be making an LED screen material which from a distance doesn't really look like much, but if I go ahead and zoom in, you can actually see the individual pixels of the screen. Now, the fun part about this is that most of this is done by material, so if I go to the right side to my material instance, I can actually set the resolution to 512 by 256 and it will actually pixelate the image to fit this. I also have added a few stuff to avoid the moiré effects, so we fade out the material at a distance and also at an angle, which avoids most of the moiré effects. You can also stop it from pixelating the stuff, so you can go to pixelate texture here and turn that off, so you can have more of a masked effect if you really wanted to emulate a CRT. You can also easily change out the LED material, so if I go to the pixel texture over here, I can change this to LED offset, and if I do that, now I have more of an offset texture. The possibilities are endless with this, so without further ado, let's get into the video. Okay, so here I have a basic scene inside of Unreal Engine. It's just a first person template, and before we can make an LED screen we need two textures. The first one's going to be the main texture, aka the texture you want the screen to display. The second one's going to be the pixel texture that is overlaid on that main texture. So for the main texture I'm going to be using this one I made. I'll have a link to the original file, but I made a few changes to it. So what I did is I set the dimensions to 2048 by 1024, so it is a rectangle which is supported by Unreal Engine. So practically I just customized the resolution to fit Unreal Engine standard. So then you're also going to need the pixel textures. So down in the description I'll also include a zip file with 3 pixel textures I made. I'm going to primarily use the TLED texture over here, but I'm going to explain both of these later in the video if you want to create more variation for your screen. But anyway, what we want to do is we want to import our base texture. So this is the one I'm going to be using. I'm going to open up my content browser and drag the TLED screen in. And then I'm going to open up my content browser and drag the TV screen pixel in here. So this TLED pixel I'm going to drag in over there. And then these are the two textures. So of course for these textures we need a material to interact between these. So we're going to right click in our content browser, click on material, and we're going to rename this material m_LED screen. And we can then go ahead and double click to open it up. We're going to drag it from the top and dock it to the main window. And now that it is docked, we can go ahead and add our two textures. So we're going to scroll out a bit and find an open spot. I think here is about fine. I'm going to open up my content browser and I'm going to drag my TLED screen texture in. So this is your base texture you're going to be using. I'm going to drag that in, okay? And then I'm going to just move down a bit for open spot. I'm going to open up my content browser and drag in the TLED texture. Okay, so why am I spacing these out apart? Well, we're going to add a bit of code at the UVs of these, and so having them close to each other just makes things messy. So how do we easily connect them? Well, with named reroutes. So if I go to this texture sample over here, and I drag out of this RGB value, I'm going to type in named, and there's going to be this option, add named reroute declaration node. You just want to select that. We're going to call this LED screen base. Should be a good name for it. So this is our base LED screen without anything done to it. Then we're going to move to our pixel texture, drag off the RGB and type in named reroute. We're going to find this add named reroute, just click that again, and this one we're going to call LED pixels, and that should be a pretty good name. I'm just going to move that up there. Okay, and now that we have both of these sorted, how do we actually overlay this texture over this one? Now I've seen a lot of people, they do masking and stuff like that, but thanks to our texture already being in color, all we have to do is multiply both of these together, and then this is like practically 90% there. So to do that, we're going to go close to our m_LED screen, we're going to drag off the emissive color, we're going to type in multiply, and we're going to add the multiply node. And the top value, we're going to make our LED base, and the bottom one, we're going to make our LED pixel. So we're going to drag off the A value and type in LED, and we're going to select LED screen base, and we're going to drag off the B value and do LED pixels. And if we go ahead and apply, you should see that we have this. Now, the problem is, right, a TV is not a ball, so we need a better way of viewing this. If you're in this corner where you have the material ball, you can go to the top, well, not the top, the bottom right. You'll find the third option is a plane primitive over here at the 5 buttons. If you click on that, now you have a plane as a preview, which is more fitting to preview television stuff. Anyway, as you can see, the colors are masked correctly. The blue is on the blue channel, the green is on the green channel, red is on the red channel. But there's one big problem. This is a singular pixel, so we're going to need a bit more than just one pixel. So how do we add more pixels? Well, to do that, we have to go to our LED pixel area here. And what we have to do is we have to tile our pixel texture. Now, the easiest way to do that is by right-clicking next to the texture sample and typing in texture coordinates. And we're going to add one of those. Now, if we connect that to the UVs, nothing's going to change. But if I go to the U tiling here in the details panel and set it to something like 10, you can see there's now 10 pixels on the width. And if I go to the V tiling and set that to 10, there's 10 pixels on the height. Now the problem is, well, it's not really a problem, but I don't like messing around with texture coordinates. Usually I do the math after the texture coordinate, so I can just use the same one over and over without issues. So what I'm going to do is I'm going to set both of these tiling values back to 1. I'm going to disconnect the texture coordinate from the UVs, and I'm going to move it a bit to the side. Now I'm going to drag off of that and do a multiply node, which is going to do the same thing. Now if I connect this back to the UVs, the multiply endpoint, and I set the B values to something like 10, it does the same thing. But we have a problem. If I set this to 100, you can see it's going to be 100 by 100 pixels. But we have a rectangular image, or at least I have. So how do I make this more adjustable? How can I adjust every axis of the display? Well, what you can do is you can drag off the B value and type in append until you find this append vector node. You just want to add one of those, and then the A value is going to be the X resolution and the B value is going to be the Y resolution. Now, of course, if you have stuff that you want to adjust easily, you want to make parameters, so you can do that in a material instance. So what we're going to do is we're going to hold 1 on our keyboard and left click. This is 1 in the number row, by the way. And what you want to do is you want to right click on the 0 and convert it to a parameter. We're going to call this parameter screen res X. And we're going to connect that to the A value, and we're going to click on it and press Ctrl D to duplicate it, and we're going to move it to the bottom and connect it to the B. We're going to go to the bottom left under the details panel and rename it to screen res Y, and now we have 2 parameters. But as you can see, our image is now blacked out, which doesn't make sense until you notice that our pixel values are actually 0. So what we're going to do is, as a default, we're going to make the pixels actually the realistic amount of the texture. So if I open up my constant browser and go to the texture, you can see that the texture is 2048 by 1024. So what I'm going to do is this is going to be the X, so this is the width. This is going to be 248, and the bottom one here, the Y, is going to be 1024. Okay, so this is now 100% ready to go, but I think we're going to take this texture sample, right click it and convert it to a parameter so we can easily swap out the pixel texture. Okay, so we're going to name this LED pixel texture. Okay, and we have that sorted. And of course, while we did this, we can just as well go fix the LED screen base one by right clicking on it, converting it to a parameter and calling this the LED screen base texture. Okay, so now we have the parameters set up. So let's go test this. Now the problem is, right, that this is a square texture or square plane, so we can't really test the accuracy of this because this is now rectangular resolution. So what we have to do is we have to create a rectangular plane to test this. So let's go ahead and do that in our level. We're going to go to the top left, click on apply, save, and go to our first person map. Then we're going to go to the top left here to this quickly add to project button. We're going to go to shapes, go to plane, and drag that into our scene. Then we're going to just rotate this to, you know, face us. I'm gonna move this out a bit. And what I'm going to do is I'm going to scale it to, let's say about 4 on the y-axis. So that should be pretty good. And I'm going to scale it to 2 on the x-axis. And this is pretty decently sized. So then what I'm going to do is I'm going to open up my content browser, drag in my MLED screen, and as you can see the rotation's a bit messed up. So what I'm going to do is I'm just going to rotate this, scale it down here, and scale it back up here. Just make sure that your fin is a rectangle if you have a rectangular image, or it is a square if you have a square image. But if we zoom in, you should see it is actually square pixels. Now, of course, they are very small, so my camera clipping plane is going to hit it. But we have a problem already. If I go in here, you can see there's a greenish tint when we zoom in. So when I'm further away, it's fine. And when I go in, it's green. So what causes that? Well, that has to do with the compression settings, right? So the problem is that if you use the default compression settings, it kind of cuts down on the green, which kind of causes this weird issue. So to fix that, you want to open up your content browser, you want to open the TLED screen texture, you want to go to the right under compression, and under compression settings, you want to change the default DXT1 to, let's try user interface 2D, and we're going to save that. And once you do, now that greenish tint is gone and that is fixed. So that's pretty good. Now we also have another problem, or it might not be a problem depending on how you feel, but as you can see, these textures, these pixels, they aren't actual pixels. Now, how do we test this? Well, it's pretty simple. We're going to go to our MLED screen, and let's go ahead and half both of these values by just doing like a stripe through and dividing them, and hitting apply and save. Now, if I go look at the pixels, you can see there is multiple colors or multiple shades of a certain color under a pixel. Now, that is not realistic. Pixels can only show one hue of a certain color, can't do gradients like this. This is more CRT fin to happen. But, so how do we fix this? Well, the easiest way to fix this would be by going into your content browser, going to the TLED screen, going to the right side, setting, well, by scrolling down also, until you find this advanced section under the texture section. And if you see here, when you click that drop down, there's going to be this filter option. If you change this from default from texture group to nearest, now the texture will be pixelated. And if I hit save, then it's going to be pixelated. But still, it isn't correct because there is 4 pixels in 1 pixel. So that has to do with our resolution. So if we set this back to multiply to the default value and hit apply and save, then it's going to be accurate real pixels. Now, that would be the ideal way to kind of do it, but the problem is for me is that's like really a lot of setup, and I don't really know the resolution I want for stuff until I like get to that stage where you're further in development and you're checking how to improve the visual effects. So what I do temporarily, or what I do mostly, is I actually pixelate the texture inside the material. So what I'm going to do is I'm going to go to my TLED screen, I'm going to set the filter back to default from texture group, and I'm going to save that. And I'm going to go to my MLED screen, and this code I use to multiply the pixel texture, I'm actually going to select this and press Ctrl copy to copy it. Then I'm going to move this to this LED screen based texture, and I'm going to press Ctrl V to paste it. And what I can do is I can drag off this multiply and do a seal node, which is sealing, so that already makes it blocky. But to get it to the perfect value, you have to do 1 divide off of that, and then you have to connect this bottom append to that, and if you connect that to the UVs, and hit apply and save, now the resolution that this is will actually downscale the image to fit that. So if I set this to, let's say, 512 by 256 and hit apply and save, then it will actually pixelate the image to fit with those pixels. Now that's pretty cool, but we can improve this. But first we have to solve a new problem. If I zoom out, right, you might see that weird glitching. It has these lines and they flicker. But why do they flicker? Why is these lines appearing? Well, the reason these lines appear, this is practically called a moiré effect. I believe that is how you say it. Please don't hurt me if I mispronounced it. But the idea is that some grids or some patterns are very hard for cameras and computers to render because they kind of are too small, so the detail kind of fights each other to get to the main, to be the thing that has to be rendered. So this happens because there is too much detail, kind of. Now what we need to do is firstly, make sure your texture settings is correct. So if you open up your content browser and go to your TLED texture, you want to make sure your MIPGen settings is on from texture group and that it is not on no MIP maps. Because if I set this to no MIP maps and I save, then you're going to see it's way worse, but so we're gonna not use that. So you want to make sure that's from texture group. That will ease out most of it, but we still have some of it there. So how do we fix it? Well, it's pretty simple. If we go pretty far away, it doesn't appear anymore. So what we have to do is we should probably fade the pixel texture out based on distance so that when we're close to the screen, we can see the pixels, but if we're far, we can't see it, and so that glitchy pattern can't appear anymore. So how do we do that? Well, we'll go to our MLED screen, and we'll go to where we did this multiplication with the LED screen base and the LED pixels. Then we're going to move this a bit to the left to make space. I think I'm going to select everything here and move it a bit to the right, because this might get a bit messy. We'll clean that part up now, but what we're going to do is we're going to drag off this multiply node over here and type in linear interpolate. So what happens is the alpha defines if we should have the pixels on or not. So if the value is 0, then A is picked. If the value is 1, B is picked, and anything in between kind of like picks between these two. Anyway, so how do we get an alpha that will work here? Well, we can right click and type in camera depth fade, and we'll use this node over here, so just click on that. And if we connect that to the result, now we have something that can work with distance. But how do we know this is working well? Well, if we right click on this camera depth fade and click on start previewing node, what will happen is if I'm far away from the screen, it will be white, but if I'm close, it will be blacked out. So the parts where it is blacked out is the parts where the pixels should display, and where it's white out, the pixels will not display. Okay, so there is two main settings that we'll be using for this. There's going to be the fade length, which is for how long this kind of blends in between 0 and 1, and there will be a fade offset. This is the offset at which this fade begins. So if the fade was 0, for example, and the fade offset was 500, then the moment I hit 500, the pixels are fully loaded. So let's go ahead and set variables up for these. What we're going to do is we're going to hold one on our num key row, so the key row at the top of your keyboard. We're going to right click on that and convert to a parameter. We're going to go ahead and rename this to LED pixels fade length. Should be pretty good. And we're going to connect that to the fade length. I'm going to set the fade length to a value of, well, I'd say 200 is good. And then we're going to go ahead and duplicate this node by left clicking on it, pressing Ctrl C and pressing Ctrl V, and then we're going to go to the bottom left and rename it from fade length to fade offset. And we're going to connect that into the fade offset. I think a default value of 500 is good in this case. And now let's connect this into the emissive color. So what we should see is if I right click on this camera depth fade node and stop previewing it, what we should see is when I'm close, there is pixels rendering. When I'm further, it's white out. So why is it white out? Well, we haven't connected anything to the B value. And what do we have to connect to the B value? Well, we have to connect an unaltered version of this base texture. So what we're going to do is we're going to take this LED screen base texture node over here. We're going to press Ctrl C and Ctrl V to copy and paste it. And then I'm gonna drag this off this RGB value and do a named reroute. So we're gonna add named reroute declaration node. We're going to call this LED screen distance texture. So distance fade, LED screen distance texture should probably be a good one. So this is the texture that will be displayed at a distance. And now all we have to do is when we go back to the lib, we just drag off the B value and type in distance. And we should find, let me just see, our LED screen distance texture right above everything else. And so if I move away, you can see that we actually are fading correctly. So let's hit apply and save and see if that's helped. So yeah, we still have that flickering, so we're gonna have to adjust the value. We're going to do that now, but we have a new problem as well. If I move pretty far away from the monitor, you can see it kind of becomes brighter. That's because these textures have a black outline, and that black outline actually ruins the quality of, or practically the brightness of the image. So the moment you don't render them, the image is way brighter. So how do we fix that? Well, there's two ways. You can make the pixel textures brighter, but my preferred is to actually just dim the further away texture. So how are we going to do that? Well, we're going to go to our MLED screen material. We're going to our screen distance texture over here. We're going to drag the base texture away. We're going to drag off the RGB value, and we're going to do a multiply. And we're going to connect the end of that into there. And the B value is going to be like a brightness setting. So what I can do is I can hold one on my keyboard again, left click, right click, and convert to parameter. And this will be the LED screen fade texture brightness. So this will be the brightness of the texture further away. So if this value is on 1, it will be full brightness. And what I found is 0.3 is a good fade value, but you can of course adjust that. That's why we have that as a parameter. Now if I hit apply and save and I move, you can see the color transition is not as abrupt and it's pretty smooth. But we still have that glitching effect. So what should we do in that case? Well, we're going to make a material instance so we can easily adjust this. We're going to open up a content browser. We're going to right click on our MLED screen. We're going to create a material instance. We're going to call this mi_LED screen. So mi for material instance. And we're going to drag that onto there. Then we're going to open up a content browser. Go ahead and double click that. Move that and undock that. Go to a first person map, and we're just going to make this a bit larger so that these settings are easier to see. And now what we should do is we should adjust the fade length and the fade offset to hide this. So here on the right side, we're going to check on fade offset. We're going to reduce it until we see less of that. As you can see, that practically disappeared. And when we get close, the pixels are there. So I think a value of 250 in that case is pretty cool. Yeah, that's really cool. For different types of monitors, so different sizes and different pixel resolutions, you are going to have to play around with this to get a value that works for that specific like screen resolution. So this is why this is a parameter. Anyway, now that we have fixed most of that, there is still one case where that flickering can happen. So if I move into an angle, sometimes you can see that flickering based on distance. So let me just actually raise the fade offset. It might be very hard to see on YouTube, but there is a slight flickering over there. And this is caused because you're watching at a too steep angle, which is where the grid also becomes way too small and hard to render. So in that case, we're just going to set the default value back to 250 over there. We're going to save that. And in the cases of that, you probably want to fade the pixels away at an angle as well. So how do we do that? Well, I'm going to go back to our MLED screen. We're going to move over here, and after this lerp over here, we're going to do another lerp. So let's go ahead and copy this lerp node and connect this into the A value, connect this into the emissive color. gonna move both of these to make a bit of space, and now we're gonna need an alpha. Now, there is a few ways to calculate angles in materials, but in this case, a very fun and easy way to do this is by right-clicking and typing in Fresnel. This is called a Fresnel shader, and what it does usually, we're gonna click on that, is that it outlines objects so you can make a glow for your objects. But in this case, if we right-click and start previewing this node, and we move from an angle, you can see the white parts are the parts that will be rendered as non-pixels, and the black parts over here will be rendered as pixels. Now, as you can see, there really isn't much black. That's caused by the base reflex fraction in, so you just want to set that value to 0. And if you do that, now you have a better gradient. Now, if you reduce the exponent in, then there'll be less pixels visible in on your screen. But if you set this value higher, let's say something like 10, then at a very steep angle you will start to fade. Now, personally, the default of 5 is my preferred, but you know we have to make this a parameter. So we're going to hold one on our keyboard, left click, right click, and convert to parameter. We're going to call this LED pixels fade Fresnel. So I'm just typing everything in caps. LED pixels fade Fresnel or Fresnel, and we're going to call this exponent because that's the setting we're editing on the Fresnel. And we're going to connect that into the exponent in. We're going to set the default value to 5. And now we're going to connect that into the alpha, right click and stop reviewing the node. Now, of course, as you can see, at an angle, it just renders white. So what we have to do is we have to get our LED screen distance texture, control copy and control V it into there. And now at an angle, it actually fades out this texture, causing or fixing some of that flickering issue. So this is a pretty much full complete shader. So I'm going to just help you clean up the shader code a bit. So just compartmentalize a bit of it, show you a few important settings, and then I can show you what you can do if you want to have offset pixels or stuff like that. So let's go ahead and fix the material or just make it a bit more cleaner. So to do that, we're going to go to our MLED screen. We're going to go to the bottom of our pixel texture code. We're going to move all of this closer, select all of this, press C on our keyboard, and we'll call this LED pixel. So this is where the pixel code is. We're going to move to our screen-based texture, move this a bit closer, select all of this, press C to comment, and we'll call this LED screen base. Okay, and we're going to move over here to the screen distance texture. We're going to select all that, press C, and call this LED screen distance. So this is how the screen will look at distance. Okay, that's perfect. And we're going to just move that over here. Now, also, another thing we can do if I just move this closer is that you might not want this pixelation to happen on your main display. So what we can do is we can actually make it a setting in the material instance. To do that, we're going to expand the LED screen base over here. We're going to select all of this, move this to the left side, and we're going to drag off the divide and type in switch. And there's going to be the static switch parameter. If you add this, this will make a parameter where if you can change the value to true and false, and based on that, it will do stuff. Okay, so we're going to rename this pixelate texture to fit resolution. I'm going to connect that into the UVs, and we're going to set the default value to true. But if we're false, we have to input something. What we can do is we can just import the basic texture coordinate. So I'm going to drag off the false value and type in texture coordinate. And now we have a way to control that. And that's pretty fine. I think that's good for now. So now that is cleaned up and is looking pretty sharp. But here's a mess where we don't really understand what's going on. So we're going to move this over here. And we're going to call this, we're going to select this, press C, and this will be multiply the pixel and display texture. So this means that we're actually doing the main stuff over here. And then we're going to move these nodes over here to the right. Select these nodes, move them into their own small bit. Move that up there, move that up there. Select all of this, press C. We're going to call this fade pixels based on distance. Okay. And then finally, we're going to move this up a bit. We're going to select all of this, move this closer together, select all of this, press C, and we're going to call this fade pixels based on angle. Awesome. And this should be good enough. This looks pretty clean. So if we can just quickly make or take a look in the material instance. So we'll hit apply, save. Go to the first person map, open up our content browser, and open up the material instance. So here we have the texture settings. We can easily replace the pixelate texture. Here we can set pixelation settings. So that is pretty cool. We have screen resolution, we have the fade. Yeah, everything we need here is pretty much sorted. So we can just go ahead and save here. And now, one more thing before I leave is, well, we don't have to use the specific pixel texture. Now, down in the description, I have, of course, linked a zip with more. So I'm going to talk about these. So firstly, we have the LED offset texture. Now, if I open up my content browser and go ahead and drag that into the Unreal Engine, open up my content browser again, go to this TLED offset texture, go to the compression settings and set this to user interface 2D and hit save. Then if I want to replace my pixel texture, all I have to do is open up my material instance and change the LED pixel texture for this LED offset texture. And if I hit save, then I have this cool little offset thing. But it isn't correct because practically one texture resembles 4 pixels, but Unreal Engine thinks that it just represents 1 pixel. So what can we do to fix that? Well, generally the easiest way to just line it up is by going to your MLED screen, moving to the code that determines this pixel stuff. What you can do is you can just set these to half the resolution, and half this means that it will be double that. It's really weird, but one of these pixels is actually 4 pixels. And also this pixelation code will not work for this, because this is more for uniform pixels, and this isn't uniform, so it's never gonna line up. So what we're going to do is we're going to go to our MI material instance. We're going to turn off pixelate texture. So if I do that, this looks way more natural. And what I can do now is if I go to my material instance and set this screen res to 256, and set the screen res Y to 128, and I hit save, then this will be the equivalent of 512 by 256. So it'll just be the same because 1 pixel texture is double the pixels. And now that creates a pretty cool effect. So if you really want this offset pixel thing, you can go for that. Also, we have this other CRT texture. So if I open up my content browser, take this and drag it into there. And now if I replace my screen texture, so if I go to my material instance and go to, the material instance and change this for my CRT, and I press apply, then it will kind of be like a circle renderer. Now, the thing is that this does not have any color information in it. So, as you can see, it is fully white out. That's because if I were to make a color one, it would be very hard to tile the specific texture. But if I were to set this at, if I go to my material instance LED screen, I set this default value to 512 by 256, then the pixels are smaller, and if the player comes to look at it, it still looks pretty decent. So that's if you want to go for a more CRT style there. Again, I mean, that is practically all the pixel stuff. So one more thing before I go is I'm just going to duplicate this texture over here. I'm going to size it down over here, just to show you. If I move this up as well, just to eyesight. If I come and go play, look at the screen, it might be hard to see the pixels overall. So in that case, if I go closer, you can see the pixels. In this case, it is very hard to see the pixels. For a screen like this, you would rather create a new material instead, but I'm going to use the same one. If I set the value to 256 by 128 and hit save, then you can see that this looks way cleaner. But also remember, based on whatever resolution you're working on, you might have to set fade offset or the fade texture brightness. Just play around with the settings. There are quite a lot of settings to mess around with. But before I go, finally just one more cleanup and then we are done. I'm sorry for going on so many tangents, but we're gonna be done now, okay? What we're going to do is we're going to select the screen-based texture. We're going to go to the bottom left and we're going to change the sampler source from texture asset to shader wrap. Now, if you are using the unfiltered texture method, where you are specifically setting the texture to unfiltered and setting the screen resolution yourself, then you would want to use texture asset because that's the only way to get a nearest filtering. But for this method over here, I can just use shader wrap. And I can also do that for all of them. So what this allows us to do is this saves us some texture samplers so that we can sample more textures and make some more cooler effects. So you can just add more textures in your material without having to worry about Unreal Engine's limitations. Or well, it's more for DirectX limitation, but you don't have to worry about those limitations anymore. But yeah, that's it. This is the fully completed material. It is ready to go. The pixels work, this pixels work. I can, of course, go back to the material instance, change the spec to the LED material, save, and yeah, this looks and works pretty well. So yeah, thank you guys for watching. If you like the content, please subscribe, hit like if you liked the video, hit dislike if you didn't, and see you guys in the next one. Good night, everybody.